we're not really top predators because we don't fit in the ecosystem. We engineer everything to stop. And when our food supply was going down, in the Victorian period, what did we come up with? Artificial fertilizers, because we didn't have enough manure to go around. So we came up with artificial fertilizers, right? When we're thinking about climate change or trying to out engineer climate change, we're not going to modify our practices or our birth rates or anything like that. God forbid, So I don't know. We're a weird species.
If you've ever wondered, outside of the media hype, what sort of damage we're doing to the world's oceans, then this conversation is for you. I speak with marine biologist Shawn Robinson, who's an expert on the study of shellfish and sustainable aquaculture. We discuss a holistic view of aquaculture that combines elements of biology, physics, economics, sociology, and government policy. Our conversation ranges from diving with giant octopus and doing research in submarines, to the life cycle of fish and designing experimental farms, to the politics and economics of what ends up on your plate. I'm Shane Farnsworth, and this is the Escape Sapiens podcast. If you enjoy these conversations and want to help support me, the best way you can do so is by liking, sharing, and subscribing. And now, I'm pleased to bring you Shawn Robinson. I hope you enjoy.
Escape Sapiens.
Shawn Robinson, welcome on the podcast.
Thank you very much. Glad to be here.
So let's start with a sort of get to know you type question. How did you first become interested in marine ecology and aquaculture? Was it that back then you were worried about the state of the world's oceans, or was it still that you were interested in discovery and new things? What was the drive back then?
Oh, I think I've always had that drive. I mean, even as a kid, I grew up for a part of my life in Nova Scotia and Prince Edward Island. And I was on the shore all the time, dragging stuff along, watched Jacques Cousteau, of course, in some of my earlier formative years, like a lot of my generation. And so I was hooked on the ocean right from the get-go. And so that led to me doing, an honors degree at Acadia University, and it led to me doing a master's degree at Simon Fraser with Brian Harwick out in BC, working on the giant Pacific octopus. And then it led to me doing a PhD out at UBC, on marine, biological oceanography and fisheries linkages, out in the Strait of Georgia. So, I think I've always had this bug, and the fisheries and aquaculture are all, parts of the same puzzle as far as I'm concerned. And, it's from marine production, from the sea. And that's always been sort of my theme.
So what sort of research projects get you excited then? And is a standard day out in a scuba tank under the ocean sort of observing, or what does it look like when you're actually doing research?
Well, I think my background is as an ecologist. So it's one of these, jack of all trades and master of none almost. So, as an ecologist, you're almost like the conductor, right? You need to understand how all the parts of the system work together. And I think that's sort of been my focus, for a lot of it. And that's sort of brought me along into looking at systems, like how does the system work? For example, my PhD was on larval Pacific herring. And, herring spawn up and down the BC coast, but they don't spawn everywhere. And the question is, why do they spawn? And spawning beds are stable over long periods of time. They go to the same areas every year. And you could change the name, like from Pacific herring to mackerel, to sharks, to whales, to seals, to snails, to whatever. These strategies have been worked out over millennia. And so trying to understand why they do what they do gives us an insight in how the environment works. So that's what sort of stirs my juices. So, we found that, the herring would spawn in areas that were high in primary productivity, and that there was retention areas there. It's almost like nursery areas that would keep these larval fish in place while they do that. And, when you expand that, how do fish stay on seamounts, right out in the middle of the ocean when there's tons of current going? How do you get any fish on there at all if they have a larval stage? Well, the point is that there's physical processes that allow them to stay there and provide, nourishment for them. And trying to understand how that works is key to understanding how to manage it or leave it alone or whatever we decide we want to do with it. So that's always been my drive, trying to understand the system and then how can we fit into that system.
Hmm.
And that's
How
really
do
the art.
how do animals know to go back to the spawning grounds? I mean, is this somewhere in the genetics that this information is stored, or do they learn off each other? Because some species, for example, salmon, they die after they spawn, right? So no one can teach them. How do they know to go back to the same space plots, which can be huge distances away, right?
Sure. Well, I think there's both a genetic and a learning component to it, right? I mean, if you have a multi-year class population, then older individuals in that population can become the lead, to do it. And you see that already with, you can look at herding animals, right? Wildebeests, whatever, elephants, birds, like the mature members of the flock do that. And it's not surprising. You will probably find that in fish too. So that's one way. And of course, there's also a genetic component. I mean, if there's a selective advantage to being able to recognize natal waters, for example, in the salmon, right? You go into that water, and if over millions of years, your genes have evolved so that you remember that particular smell, and that becomes embedded, then you can come back. And it's not magic. I mean, it's just that they've had the luxury of millions of years to kind of get it right. And those that don't, of course, don't contribute their faulty genes to the population, for that. So you can see how that would work. There's physical areas that retain things, and that was part of it's one of the classic fisheries theories, right? The member vagrant hypothesis was put forward by a couple of scientists, Canadian scientists, actually, Mike Sinclair and Derek Isles, talked about, how do populations exist? And they suggest that it's the size of the retention area that does that. So, are you familiar with gyres?
Not at
So
all.
gyres are okay. So gyres are just like whirlpools, right?
Mm-hmm.
And if you think an analogy would be, when all the leaves fall in your backyard in the fall,
Mm-hmm.
right? They don't always evenly coat your yard. They pile up in certain areas because the wind blows them there, right? And that's the same in the ocean. And those areas where leaves accumulate in the ocean, they're called retention areas, and they're basically whirlpools and circulation patterns that tend to maintain things. So when you get these zones of retention, that allows a whole bunch of other dynamics to happen, such as stratification of water, maybe.
Mm-hmm.
If it stratifies, then perhaps it's a bit warmer, perhaps it's more productive because phytoplankton can get more light and more photosynthesis going on there, which then trickles down the whole food chain. And now you've got all the sort of, zooplankton there, which attracts fish and all the way down the food chain. You see the same things with upwellings in the Benguela Current off Africa. All of these things that go on are things that animals key into, and we're oblivious to a lot of them. So it's up to ecologists to try and figure out where that is and what it means.
If we're oblivious to a lot of these aspects, how on earth do we breed? So later on, we're going to talk about aquaculture. How do we breed salmon then? Because their natural life cycle has them swimming upstream and all these complicated processes. How do we put that into a cage? Especially for some of these species, if we don't know the full life cycle.
Well, we do know the life cycle of salmon. I mean, that's not new, and because of the primacy almost of the salmon, Atlantic salmon has been studied for a long time by Canadians, Norwegians, the British, the U.S. I mean, it's been a key species. There are huge industries that were based on that before. Like if you go to England or somewhere or Scotland, I mean, there's still areas that are owned or that were owned. I don't know what it is now. I'm not living there, but I mean, there were massive rivers that were owned by the lords, and they had the exclusive right to fish there. So, this has been a long history of prestigious fish, and as a result, and because of the industry that went along, the canning industry, the netting industry at sea, I mean, they learned a lot about them. And a lot of the early physiological work, some of it was done in Canada here by some of the people at Department of Fisheries and Oceans, I mean, led to a lot of the basic biology, understanding the basic biology that went into husbandry. Like, how do we? And then they started looking at stocking and restocking, areas and catch and release. And I mean, that whole technology's moved on to either containment aquaculture, where the fish are bred in, and there, it's like cows, right? I mean, the original cow or chicken does not look like the chicken that we're eating now, or the cows that we're eating now. I mean, they've been bred for husbandry. So those that are too sensitive, like nervous, that those ones are gone. I mean, most of them are calm. They're bred for being in cages and whatnot.
The farm salmon that we eat is different to the wild salmon then? I didn't know that.
Well, it's the same species, but it's like dogs and wolves and that sort of thing, right? I mean, a lot of the wildness has gone. Like a farm salmon is genetically different, in some aspects, mostly phenotypically, than the wild salmon.
Would they still follow the traditional salmon run if they were released, or that's gone?
Sure, but yeah, no, they're probably doing that, but they're probably not doing it as well. And I don't know, we're getting a bit outside of my area of expertise on salmon behavior and what's going out there. But when fish are accidentally released from a cage, they don't necessarily join a school of salmon and head to the North Atlantic or something. Some of them may, but a lot of them will just mill around the farm because they've been used to sitting in a cage, swimming around, and being fed regularly. Whereas now all of a sudden they have to go forage on their own, and there's things with big teeth out there that probably want to take them to dinner. So, like sharks and other things. So, it's a whole different world out there. Like releasing, somebody who lives in, downtown, third generation downtown London or Toronto or New York, and dropping them in the middle of the,
Kalahari
the
or somewhere.
North. Yeah, or the Kalahari. I mean, they're going to last for a day.
Well, then let's jump back into something that's more along the lines of what you've been working on directly.
Sure.
I was looking through your papers, and I think, correct me if I'm wrong here, the first paper that I saw was in 1983. So that's 40 years ago.
Yeah, that's probably right, sometime around there.
So the obvious question is, what's changed during the course of your career then? Have you seen obvious changes in the ocean itself? Have fishing practices changed? How has our understanding developed in that time? It's a very broad question, but if there are some standout features over those 40 years.
How has it changed? I think it's changed. Like there's a number of elements. You could look at that on a number of different levels. How is the whole fishery perceived, or the marine food production? I mean, initially it was fishery because there really wasn't any aquaculture, at least not in the Western world anyway, to any great extent. I think people have lost contact with the oceans and the things that go on. Like if you went back 100 years, and that's about the age of our discipline, really, right? I mean, if you go back to the 1920s, I mean, this was pre-computer, pre a whole bunch of things. And I mean, we were basically looking at fishing, but people were aware of the communities and the fishermen or the fishers that were in the community. They brought revenue in. Was it a high social status? Probably not. Because, there's tales of, fishermen's kids going to school with, what we consider a gourmet meal right now, like we're taking lobsters to school and all of a sudden, trading for peanut butter or something like that. But I think we've lost a lot of that. I mean, if you look at the political portfolios that are put out, the Minister of Fisheries and Oceans probably isn't one of the plum positions as opposed to the Minister of Finance and whatnot. and so you see the support for fisheries going down. And so how's it changed? I think it's less important in Canada right now than it has. Now, that's not to say it's not important regionally. It's just that on a bigger basis, and Canada is just a reflection of everywhere else, right? I mean, it's just one of the G7 countries, and they're part of. I think you'd probably find the same patterns going through the EU and going through the US and other things. Is that fisheries are interesting, but they're not producing the same amount of revenue as some of the other industries there, but they're important to regional economies. So the small towns that are based on that may not have farming or other things available. So how has it changed? I think that we've been looking at technology's grown tremendously. So when I first started going out, I mean, it seems like I've always been associated with fishermen, going out with them. And some of my earliest ones were open boats, like they were probably, I don't know, 10 meters long, maybe. But they were open. I mean, there was the tiny little, cuddy, which was, maybe a meter by a meter high in the middle of this, looked like a big dory. And we would head out into the fog. There was no radio, just a compass. And this guy would go out and come back and pull traps and, that sort of thing. Now the boats are all programmed with GPS plotters and autopilots and radars and sounders that can differentiate bottom types and pick up fish schools and track them. And I mean, it's incredible what's out there on the boats to navigate. And the hydraulics, the power of the boats, the fishing power has gone way up. And the degree to which they can range. We've changed a lot of our management methods out there. It used to be wide open fisheries for the most part, but then that went to sort of, well, there needs to be a quota on it, like we're capping what you're allowed to catch. And there's then some of those become individual transferable, and it becomes more of an economic basis, and bigger companies have emerged from that control large sections of some fisheries, not all of them. So it's become large business for some of them. And as we go international, I mean, because of the fishing power that's come on, now we have the ability to go anywhere in the world and fish anywhere at any time. And, China's kind of showed that with, the ranging of their international fleets around in all the oceans of the world. So I think, that's changed. I mean, we have aquaculture. It's come in over the last 30 years. And that's gone from small mom and pop operations to large multinational companies now that are, integrated and, vertically integrated, right from feed production through production to processing to healthcare to you name it. So there's been a massive change in the industry, like the fishing and farming industries on the oceans. But we're in that weird area of we're a tweener almost, right? In the sense that we're on the oceans, we're migrating now between hunting and farming. And we're in all of the social upheaval that comes when that comes around, and all of the social implications of it.
When you were traveling with fishermen on their boats, was that purely for research, or were you also playing a regulatory role in those trips?
No, I've been pretty much the white hat guy. So I'm a researcher that goes out with the fishermen and talks.
So they don't mind you on the boat.
No. I mean, they're not doing anything illegal while I'm there, but we can talk about things, and they can, they'll tell me things that they probably wouldn't be telling to an enforcement officer or something like that. But I ask them, questions and give them answers that they're looking for too, So for example, I mean, I was just playing hockey today, and, I gave one of my guys we play hockey with, he's a fisherman. So now he's going to take a little thermograph and he's going to put it on his traps. And so he'll just monitor some bottom temperatures for me for free, and so it's like work. I've worked with fishermen and developed a reasonable working relationship with them.
Does it actually have kickbacks for them as well? In the sense, can you increase their catches, or is there anything where you can help them in the other direction?
Not really, but I can provide them information, right, which backs up some of their cases. So for example, we had one year where I was, me and my team were looking at water temperatures in and around the area. Like, we're monitoring it for our long-term monitoring program. And, so we had data from the previous winter that showed that the water was, colder than usual. So it was about 2 degrees colder than normal at this particular time of year. And that particular time of year was when the fishery started.
Mm-hmm.
So in the spring. And so they argued that because they got a slow start and like they weren't catching the lobsters, like the lobsters weren't moving, that maybe, they would like the season extended another 2 weeks. And so they asked if I had any information that would back that claim up. And I said, yeah, we do. So I gave it to them and gave it to the managers, and they looked at it and said, okay, that seems reasonable. Data that are collected are, they're valuable, even if you don't know what they're could be used for at the time. Having a historic database of information that you can use either as a baseline for comparison or to predict trajectories into the future, for modeling, is extremely valuable and sometimes not always recognized as such.
You mentioned in a previous answer about these Chinese ghost fleets that are going out and hitting various regions in the world. One of the things I'm interested in is media representation of problems in the world's oceans. So, if you watch basically any news coverage, you'll see stories about, in Canada, whales being caught in lobster nets, or you'll hear about population collapse, or you'll hear about 70% of sharks or seabirds have died, or there are these stories that are sort of fairly alarmist. And the thing is, I don't live anywhere near the ocean, and I don't have any way of really verifying any of these stories myself, except for, I suppose, reading through the literature. So I'm curious, do you think the public is well informed and has a good idea about what is important about what's going on in the oceans? Do you think we're worried about the things that actually we should be worried about, or is the representation not good in your opinion?
So that's a wide open question. I think from a large scale look at it, I think the public really doesn't have a good grasp of what's going on in the oceans. And part of the reason for that is everybody's busy. In today's society, everybody's busy. They're on their phone. They've got this, that, and the other thing going on. There's no time. So a lot of the information comes in sound bites. And like if they're getting a news story on the radio, the TV, on a blog, on whatever you're getting your news from, they're generally 1 or 2 minutes, maybe, for the most part. There's some really good shows out there, like science shows that do a good job of pushing that information out. I can think of, in Canada, we've got something on CBC called Quirks and Quarks, right? That's a good show that brings a lot of interesting science that you would never see otherwise to the Canadian public, right? David Suzuki on the nature of things. We did a show with him or two. So, and that's a good, visual medium that gets it out, right? BBC Nature does a good job of getting, certain stories out. Even Escape Sapiens, right? I've looked at some of the stuff that you're putting out. That's good. But the range or the scope that of people that actually gets to is still relatively small. BBC is probably the biggest because it gets carried around the world by different stations, that are putting it out. But still, the people that probably need to see this, the people that are making the decisions and controlling where the money flow goes, are not getting a chance to get educated on that. So with that as sort of the background, I think the media, probably doesn't get as much of the story out as it can, because they're looking for sensational things, because they're competing for space in their newspaper and their time slots. Something has to have some sort of sensationalism to that. And so as a result, people get these sound bites. Some of them are taken, and run with by certain special interest groups or whatever it is. But for the most part, people don't take a lot of time to figure out really what's going on in the ocean. And maybe they don't have to. It's sort of like, how much do you actually know about how your cell phone works? Right? You
Mm-hmm.
don't, right? You don't know much about well, maybe you do, but maybe you don't know much about the telecommunication industries and how all of this technology works, so that you can book a dinner reservation on your phone in some other
Mm.
city that you've never been to before, but the advice on Yelp is giving you something there, right? It's the same with the ocean. People assume that everything is working in the oceans, and the media are kind of throwing little bits and bites out. But I don't think the general person really has a good feel, because they're isolated from it. 80% of the people around the world all live in cities, so they're probably not
Mm.
near oceans, and they're not getting the information that they could really use, and they're expecting it to be out there. And
Mhm.
in most cases, it's not, because of the ocean is not seen as a critical place to be investing large sums of money for understanding yet, except in cases where we want to go drill for oil, or mine for nodules, or maybe harvest some very valuable fisheries like bluefin tuna or something like that.
Then let me ask you about an area where people may have a handle on, which is or which they do interact with, since people have limited bandwidth. So now, when you go to the shops, you might see, if you want to buy some fish, you might see on the packaging there's dolphin safe labels, various labels on the packaging, which tell you, this is the fish you should buy, this is the fish you should avoid, and so on. What I'm curious about is our attention really in the right place? So do we have stickers saying that this is dolphin safe because it's particularly important from the ecological point of view and environmental point of view that we look after dolphins? Or is it just that dolphins are charismatic, and so they're the ones that get a layer? You see
Oh
where I'm
yeah,
going with
no,
this, right?
absolutely, absolutely. I think I think we're I think the sort of NGOs like Monterey Bay Aquarium and Seafood Watch Program, others, the Marine Stewardship Council. I think they all have a valuable role to play. One of the things that you have to kind of recognize is that when man goes into the environment to harvest something, there's always footprints left behind. Some of those are bigger than others at certain periods of time, right?
Mm-hmm.
So for example, if you have a midline, or a midwater fishery where you have trawls and you're looking for pelagic fish, you're trying to take those on hooks, then obviously you're catching fish and taking those out. As opposed to a bottom trawl where you're scraping along the bottom and taking up bottom animals, as well as rolling it over the benthos, or the sea bottom. So those are different. When you look at what we've done, so just as a sidebar, one of my early projects when I came to St. Andrews was to work on scallops,
Mm-hmm.
or scallops, depending on which part of the country you're in. But so I was interested in looking at how the survey worked, and as I was, it's pretty much the trawl is so many meters wide and it's pulled for so long a distance, and then they multiply that, so they figure out how many scallops they caught over that time, and then they multiply it by a fudge factor, called a scientifically it's called a catchability coefficient, but basically it's fudge factor, right? And you
And
say,
that means
well,
how many have escaped?
that's right, because scallops can swim, and maybe some of them are actually in little depressions on the bottom.
Mm-hmm.
And so they tried, and I said, well, how was that established? And they said, well, we think it came from George's Bank. And I said, well, does George's Bank look like the Bay of Fundy? No. And so I said, well, maybe we should redo that. And I said, well, I could do that. I'm a diver. We'll just go down on the drags and have a look at it. So we went down, and we resurrected this little underwater plane. The two divers could lay down and fly, and get towed behind and get towed over the drags. Now you've got several hundred kilograms of steel bouncing over the bottom with these steel chain link bags and stuff like this. And we went down to try and fly in front of the drags, and we just take a video camera Yeah, it seemed like a good idea on
Wait, so
paper at the
you're in
time, right?
front of the trawl.
Well, yeah, we're going to try and fly in front of it. So with the boat's towing the trawl, and then it's also towing us, and then we're going to fly
What
down
happens if you
over
let
top of it.
go?
Well, then we're behind. Then we just drift off into the back.
Okay, it's not that you get
Just
caught in the trawl.
no, we're above. We're flying above it so that we can try and get the cameras to look down, and then we'll just analyze the video when we come back and say, look, there's a scallop, there's a scallop, there's one. Then count them going in, and then when the drag comes up, we'll count how many are in the bag, and then we'll have our direct catchability coefficient, right? Well, that was the plan on paper, but when we got down, all of a sudden we couldn't see a thing. Like it
No.
was, I equate it to, I think I told you before, it's sort of like a smoke bomber as you're going through like fighting fires, where you're into the clear water, and all of a sudden you've got this huge big cloud of sediment with zero visibility, and then you're flying, then you come out again, and anyway, it was a fiasco with regard to trying to generate any data. But what it did show me was the impact that scallop dredges have on the bottom, because they're meant to be heavy, they're meant to dig in, and we do that, and they produce huge amounts of sediment in the water, which resettles down, of course, to the bottom. But it does a whole lot of other things to the bottom. One of them is that it changes the bottom. So on a bottom with a lot of rocks, so let's say they're random little piles of rocks all over, well, the scallop drags will scoop all of those up, and then, or a lot of them up, and then brings them up to the boat, and the boat picks the scallops out and then dumps all the rocks back into a pile. So what was a
Mm.
fairly heterogeneous environment, with rocks and all the little eddies and the ecological dynamics that go around that, are now piles of rocks, which set up maybe new dynamics. But the point is that if you towed this bit of gear across your front garden or your lawn even once, you would be absolutely horrified. Yet we do that in the oceans on a regular basis because we don't really see it, and we don't see what's going on. But if it was completely transparent, and we could, and general people could just sort of see what's happening on the bottom, then there really would be quite uneasy about how we're actually catching these things. And you could talk about deep water fish trawls, and going over coral beds. Now we try to minimize that, and there's very talented teams of people working on that within DFO and other places around the world, trying to protect these deep water corals from trawling that goes over them. But as an ecologist, that structure is one of the things that create ecological or ecosystems, right? Because three-dimensional structure will provide habitat, it provides food, it provides more food per square meter because it goes from a three-dimensional surface or from a two-dimensional surface, right? So lots of things. So it's really important to have that. And so some of the fishing operations don't do that, but we could be doing things like putting more organics in the water, and that's what happens from fed aquaculture, unless we do something to minimize that. All sorts of things that we do have impacts, and I think that comes back to how we prosecute fisheries and whether we even should in some cases.
So we're doing
So that's
the equivalent of tearing up the savannah to catch the antelope, let's say.
maybe something like that. I mean, now it regrows, of course, but when we were doing some work on sea urchins, so again, I found that being able to dive and be there firsthand provided a really good perspective. So if you, as a story, so when I first got into DFO, I get to a sea urchin meeting. So nobody was working on sea urchins at the time, so I said I might as well do that. So I went to the first sea urchin meeting with the fishermen, and they were sitting there with all their arms crossed, and I mean, who's this young buck who doesn't know a thing, and so I stood up with them, and I was nervous, and I said, here's some graphs and all the rest of the stuff, and I was showing them, like growth curves that we got from the literature, and it went over like a lead balloon. I mean, they weren't interested. That's not their language, right? And so the next time I said, I'll fix that. So I went down and I took a video camera with me. I just swam over the bottom, showed them sea urchins on the bottom where they lived, and some of the other animals around there. Didn't mean anything. I showed it at the next meeting, and all of a sudden I had all sorts of public credibility because I'd been where they hadn't. and put it out. So we started doing more work like that. And when they were using scallop gear in really shallow areas to harvest sea urchins because they had the gear,
Mm-hmm.
I said, this is a bad idea. Like you're tearing up habitat for things like that. And they said, no, it's going to be fine. And I said, okay. I just brought a videotape and showed one dead lobster on it that had been killed by a rock rolling over on it, right? That changed the whole thing, just like that. So they're able to be convinced, and we've seen that. And then
Is that because they are the same people that are farming lobster, or
not farming lobster. They would be harvesting
catching?
lobster, right?
Mm.
Yeah. And so that they could see that as an economic implication to them, right? If they're
Mm-hmm.
killing their target species, then that's not good. And so we did a lot of work, and as we were talking about the impacts on the bottom, so we started. Our water in the Bay of Fundy is fairly turbid, right? So you can't see very much, except in the winter. Like on calm days in the winter, the water's clear because there's not as much phytoplankton in it, and you can see deeper. So we chartered a plane and flew up over, above where they were fishing, and you could see this spider web of drag tracks because they switched to a lighter set of gear to go after sea urchins. But you could see the tracks on the bottom, and they covered a substantial portion of all the shallow water areas where the sea urchins were. And so over time, these guys can, if there's going to be an impact, a cumulative impact, then they can probably get to that point where they'll have an impact, in not too long. And so, but you don't see that unless you're up there in a plane, you don't get a feel for the scales, which, like a dedicated fisherman can actually, cover. And that happens every day, when we're out.
But are they not seeing this sort of impact on, why are they not seeing low numbers of lobsters? Or, your photo was enough to change behavior, but surely they should have seen just from the numbers themselves.
Well, they shifted. Well, certainly all fishermen are pretty rational when you talk to them one-on-one and stuff like this. I mean, they have their objectives, and, management has theirs. But so they're willing to be persuaded, but you have to have a good solid argument for that. Particularly if you're going to ask them to change their behavior or take less money, or in the near term, perhaps, by a change in size, minimum size, or maximum fishing season, or closed seasons, or closed zones. So it's I don't know. It's an art form to try and manage, and I mean our managers do a pretty good job of that. But you've got two opposing forces going there, because fishermen have to pretty well fish for the here and now, right? They tend to maximize revenues for the short term rather than the long term, because they can't really predict what the weather is going to be, and experience has shown them that, like the stock market, the fishing, like animal populations, do not remain steady over necessarily long periods of time. If you look at lobsters right now, we were talking about that earlier, but if you look at the long-term history of lobsters, like the landing records in the Bay of Fundy, which is one of the better, lobster fishing areas, it includes Nova Scotia and New Brunswick, lobsters were pretty stable overall for probably 75 years. And then all of a sudden, in like the mid 80s, they just skyrocketed like 700%. And the price went up with them. So it wasn't a supply demand curve. I mean, so now these guys were making massive quantities of money, from the lobster side of things, and they maximize, to that. I had some fishermen trying to, we're going to try and work on some scallops and enhancement. And as soon as the lobsters started going up, they just said, we're not interested in any of this sort of stuff. This is chump change compared to what we can make. And I mean, for a hunter-gatherer, that's what you do, right? It's just like, it's the time of plenty, you harvest. So.
And did that skyrocketing occur because, so my next question was going to be, what happens when we take large numbers of fish out of the ocean? How does that affect the different trophic levels? Are we seeing an explosion of lobsters because we've overfished, or what's the dynamics there?
Hard to say. I don't think anybody really knows why they went up. Um, if I mean, there's correlations, and fisheries often work with correlations, right? You look and see which populations are going up. You can try to infer a fishing mortality and a natural mortality and recruitment rates. And I mean, they're really sophisticated, and we've put a lot of really good science into fisheries, capture fisheries science. But and because we're really not, there's very little ecology going on out there in the marine environment as opposed to what's probably needed. We don't really know about all of these things that are they're changing. I mean, if you look at the correlations, ground fish went way down.
Mm-hmm.
So ground fish meaning things like cod and haddock and hake and other species like that. Well, some of those are predators on lobsters. We
Mm-hmm.
don't know whether it was a release of pressures that went off, but when we change things, like when we fish, we know we're going to change the population dynamics of the stock or that
Mm-hmm.
particular population, because fishing will tend to remove the largest individuals in the population, right? Just over time. I mean, if everybody's got a chance of being caught, then eventually you will be caught, and that the fishery will basically be run by new recruits or those juveniles that come in from spawning. So the average size may tend to go down in the fishery, not all the time, but a lot of times it would. But when you look
What
at reaper,
can I ask? Is that a
go ahead.
permanent genetic change?
No, it's just size selection, right? So if you start scooping, so you have a population. Once you're in the population, the only thing you do is grow, right? You grow and
Mm-hmm.
reproduce, and that your output with no fishery is you die, right?
Mm-hmm.
So the older ones, you get old and die, same as us,
Mm-hmm.
right? And so the population grows either by immigration or by reproduction, right? New juveniles coming in. When you look at the reproductive capacities, so if you were to take your fastest growing, so let's go to agriculture. So let's say we have cattle or chickens, or you choose whatever species you want, right? If you have a particular individual in your herd flock that grows really well, that's really healthy and robust, and you kill him as soon as he gets to harvestable size, then you don't have that. I mean, in agriculture, you say, well, this bull or this cow is just, we're keeping that, and that's going to form the basis of our reproductive stock. In the wild, you get some of that anyway, right? With the most fittest specimen going on and reproducing more, and I mean it brings in behavior and deer, and getting harems of other female deer, does.
Mm-hmm.
But in fishing, we basically take out the biggest, fastest growing individuals out of it because they have a higher mortality rate, because they get to fishing sooner and they get to spend more time in that window of harvest.
Mm-hmm.
So until they are caught. But often those biggest individuals have more, they can produce more eggs or sperm, and
Mm-hmm.
they could have higher reproductive output. So on the whole, we don't really know that much about that and what the particular strategy is, and how would you do that anyway with fisheries. But now that we start looking at, now we're looking at alternate forms like aquaculture of production of food. That's now where maybe we can start looking at some of these more ecological principles of what do we really want to keep. Maybe we put a minimum maximum size. For example, in striped bass fishing, in the Bay of Fundy, there's a minimum size and a maximum size that you're not allowed to keep. So you're only allowed to keep medium-sized individuals, and relatively few of those. So there are some things that we can do with that, but because we really don't have a really good feeling, and it's complicated, don't get me wrong, I'm not criticizing anybody for not knowing this, but in order to do this, there needs to be a heck of a lot more investment into finding out what the mechanisms are that make the world go round,
Mm.
particularly in the marine side. We're just getting to the point now where we're going to be relying more and more on the oceans to help feed us, right? We can't seem to get our mind around climate change and slowing the production of carbon dioxide. I don't know why, but well, I do. I mean, we're just inherently a species that is on the brink of destruction, most of the time. So, but I think that if we don't do something, to develop our oceans, we're going to have, things like droughts. So we're already talking about droughts in several areas in Australia. I mean, if we look at some of the areas in Southern California, right, where a lot of the food in North America comes from, right? I mean, a lot of fruits and vegetables and stuff like that, right? I mean, if all the water dries up in the southern US because of droughts, then what do we do with that? And, the answer may be to go where we don't need water, like the ocean, where we already have water, and we have to change, perhaps the species we eat and how we produce them and whatnot. But, if we're not looking there, and have this vision, then we're just going to bumble along until all of a sudden we've got a crisis.
So how much more productive could the oceans be if we moved away from just hunting towards industrialized aquaculture?
Well, I think agriculture holds the answer to that question, right? If you look at the people of the world right now, do you honestly think they could be sustained through a hunter-gatherer society? I
No.
mean, the answer is no. I mean, not even close. Not even 10% of what we have now could be sustained by a hunter-gatherer, approach. And so, I mean, on land, we went to a paradigm of agriculture. Now, it brought a whole bunch of other social and ecological changes along with it. I mean, not all of them good, but we're there with aquaculture now in the oceans. And so, I mean, I've done things like this back of the envelope calculation stuff, where I was at a meeting in St. Andrews here with regard to the state of the Gulf of Maine. And I was looking around and talking to people and seeing posters, and nobody could really say that the Gulf of Maine was sick, right? But they had signs that this fishery is down. The seabird colonies don't seem to be doing as well as they could. There seems to be a lack of mussels, like the blue mussel that lives along the shore, and that seems to be dying back in some areas. And there's more preponderance of diseases, and there's more invasive species. So I got thinking about, well, in typical male fashion, and if you find yourself in a hole, the first thing you should do is stop digging. So I said, well, what if we got out of the Gulf of Maine? What would happen? And I said, well, we'd lose all of the revenue that comes from that, and we would lose all of the food that comes, the seafood that comes from that. And I said, well, okay, so how much is that? So I went through from Connecticut all the way up to Nova Scotia, and I mean, just go to the fishery records, and so let's add it all up. How much was this fishery worth, and blah blah blah. And so I added it all up, and then I looked to say, okay, well, here's the total biomass that we're taking per year out of the Gulf of Maine, and you know what the Gulf of Maine is, sort of speaking. So it's
Roughly,
between
yeah.
Nova Scotia down the coast of Maine down into Massachusetts. So that whole it's a little Gulf.
So
So
a reasonable stretch.
a reasonable stretch. So I said, well, what if we put it in? So in Canada, I mean, aquaculture effectively means salmon or oysters and some mussels and some other fish on the side. But salmon's by far and away the most produced species in Canada. So I said, well, that's what we have information on. What if we put them all in salmon farms? How much area would we need to put all of that revenue and biomass in salmon farms? Now, I'm not suggesting it should all go into salmon farms, but when I do that, the math comes out that in 0.04% of the area of the Gulf of Maine, we could produce the same amount of biomass and revenue that we were taking out before. So if you were worried about whales, if you're worried about seabirds, we could get out of the Gulf of Maine and just have one small little area that we could grow it on, which would, of course, have to be distributed between Nova Scotia all the way down to Connecticut. So that's not to say we need to go into salmon farming and whatever, but the point is that if we got into more intensive culture, we could basically produce more revenue and more seafood, possibly in a more sustainable way, to support marine industries and also to support the societies in Canada and the US from the Gulf of Maine, but Europe would be the same, right? When we look at
Mm.
what we're doing, you know, 80% roughly is what we harvest of seafood produced in Europe. Same in Canada, same in the US is even worse because they don't have much aquaculture at all. But we're still primarily relying on fisheries,
Mm.
and for our main food production, and it's not going anywhere. I mean, they're managing it as well as they can. Um, they're in some cases they're doing bang up jobs. In other cases, but they're only local success stories, right? I mean, if you look at the overall catches, I think your previous speaker was talking about that, Trevor.
Trevor
Um,
Branch.
yeah, Trevor Branch. So, he was talking about, roughly it's about 80 to 90, yeah, 80 to 90 million tons a year. But that's been stable for about, well, since the mid 80s. It's
Mm.
not going up or down. So it's fluctuating. We've so obviously somebody's doing something right there and stabilizing
Mm.
some of the fisheries. But the point is that we have the human population still growing. We're at 7.5 billion people right now. If we add another 2 billion mouths to feed, that's going to put more. Everybody's eating now about 20 some kilograms of seafood a year on average.
Mhm.
When you do the math, that's coming down. Like, we're not going to be able to produce enough fish to meet that in
Mhm.
Europe or North America or whatever, which means we're importing, but from where? Asia's, it's just like there's a whole bunch of things going on. Sorry, we're rambling on a number
No,
of
no,
spots
no.
here, but
It makes me curious though. So if you can, so if I understand, you could replace fishing over the entirety of the Gulf of Maine with some industrialized, highly intensive aquaculture in a very localized region, and still pull out the same amount of biomass. My immediate question is, where does the energy come from? How what is the input that allows you to pull out the same amount of biomass from this really small amount of, are you feeding them pellets of soy that were grown on land? How do the numbers work there?
right. So as you get into the nuts and bolts of this, like I say, I would never suggest that we should just fill whole Gulf of Maine up with salmon, but we should be looking at other things that we could be doing it with, right? I mean, and that's going to come to the diets of you and I. Like, what are you willing to purchase in the stores to eat? Is it just salmon? Like, if all you want is salmon, then trying to produce something else in the Gulf of Maine is a useless waste of time. So, but you could be putting it in. So, with things like extractive species. So maybe you grow more mussels, maybe you grow more oysters, maybe you grow more seaweed. But this is where we kind of run out of options because we really haven't put any effort into trying to grow alternative species in there. Maybe there's species of snails we could be growing. Maybe we should be eating a lot more seaweed, right? If we look around the world at different spots, you would see places like Japan, or I was in China, and they have a massive number of species that they're growing. I mean, they produce some of them in hatcheries to get them over the vulnerable juvenile stage and then put them out either as recovery species, like on ranching type of things, but they grow lots of snails and clams and whatnot in bags in the oceans. And some of them, in abalone, for example, I mean, you'd be familiar with those from Australia,
Yeah.
right? They put those in bags and they grow seaweed. So they've got sort of this we call it multi-trophic system. So seaweeds and maybe some fish, maybe some invertebrates, and the seaweed sometimes get fed to the invertebrates. So you get this sort of recycling type of approach going on. And there's no reason why we can't be doing that here, but we just need to have that technology transfer or development for local species to do it. So if you look at that, you wouldn't be other than the sunlight. If you're feeding them the seaweeds that you were growing, for example,
Mm.
then really they're extracting natural nutrients out of the water. They're taking the natural sunlight and you're putting that in. They're still going to be contributing waste, from the snails or the abalone or whatever it might be. You could put that down. You could grow scallops in culture. You could grow mussels in culture. I mean, all animals that are further down on the food chain, right? So they're only like the first or second trophic levels. And then you're not putting, you're not killing other things necessarily, like wild
Mhm.
fish, to feed them. Now, in the same time, like the salmon industry has evolved way a lot from fish meal, right? They still use a lot of fish oils, right? Because you need those long chain omega-3 fatty acids. But there's there's so many things that could be done right now that probably should be done, and we're just not there yet.
So there's sort of this dream that through some sort of industrialized system, you could limit the amount of space that you need to grow, say, the protein that you need or whatever the resource is that you're trying to extract. And then you could release the large amounts of ocean just to be wild, and you'd have this very positive impact through aquaculture. But that's not really what happened on the land, right? If you fly over Europe and you look down, it's just farming as far as the eye can see, and there are no forests. So, there's these two paths. You could go down this utopic path where you release space back into the wild, but again, you could go in the other direction where we just industrialize and commercialize every square foot of the ocean, and we just become completely extractive in a much more efficient way. How is it that how can we go down sort of the first of these paths? It's a too big a question to ask you, but let me do it anyway. How do we track down this path rather than the other?
So how do we get to more efficient extraction, or
How do we do it in a way that is actually good for the environment rather than just giving ourselves more efficient systems, which then cover the entire oceans, if you know what I'm saying?
right? Well, I think we need to understand carrying capacity, like and not only the animals carrying capacity, but where we are in the human side of things. Um, I mean, a lot of our issues that we have right now, COVID, global climate change, is really human density based, right? I mean, if we had half the number of people, we'd probably half the number of issues with climate. If we're going to fish, then one of our options might be is instead of trying to catch the maximum amount of fish, and try and calculate that based on growth rates and mortality rates and recruitment rates, in there. Maybe we should just look at what the natural variability is from year to year,
Mm-hmm.
right? And say, well, look, the stock goes up and down by a factor of 5% a year on average, right? And that's because I don't know, there were storms during the breeding season. There was more predators this year than last year, whatever it might have been. But populations have evolved over millennia to deal with those sorts of population variances,
Mm-hmm.
right? So if the population goes up and down 5%, they're okay. And maybe that's where we have to fit into, and that
Mm-hmm.
would be looking at the sort of carrying capacity of um, of the of that particular environment where those stocks live. If we're going to look at growing fish, and let's say that we want to put in some fed fish, maybe it's salmon, maybe it's sea bream, whatever. Then what's the assimilation capacity of the area? And there's people working on that now, right? I mean, if you look at aquaculture, oh, there's probably 4 or 5 models that I know of already. One of them is put out, well, by some people in Portugal, and others are out of England, and there's some out of the Western US, talking about assimilation capacities on farms and how many fish can you put in and where does the waste go. So they're already working on what's the sustainability of putting it in. So I think more of that needs to be done, but maybe we should also be looking at things other than higher trophic levels as well.
Mm-hmm.
Like salmon may have its role, and in some areas, maybe we want that as a premium product, but maybe we also need to have other products coming, because right now, if we looked at all the aquaculture and the aquaculture and fisheries, and we stopped all the agriculture on land, I mean, we'd starve most of the earth, right? Because we don't have enough aquaculture to produce that, or enough food from the ocean to support people yet.
So then, what would your idealized or perfect aquaculture system be in the Bay of Fundy? Let's say, let's localize it somewhere. What's your analog of the cow, pig, sheep? What are the species you put into the system, and what does it look like?
Well, I don't know. We've worked on a number of them so far. So we've worked on blue mussels, and we've worked on oysters, and we've worked on polychaete worms. We've worked on sea urchins and sea cucumbers. We've worked on scallops. We've worked on clams. What else have we worked on? That's, I mean, and those are the ones that already have ready markets for them, which were developed by the fisheries, right? I mean, these were natural stocks out there with a market value, and that's why fishermen went after them, and that's why we decided to start working on them. But there may be other things that could be looked at as well. And you asked for my ideal world. Well, I'm not sure I have an ideal list of species, but what I would like to see is, we're in a transition time now where we're migrating between, hunting and farming now in the oceans, whether we like it or not. I mean, it's going to come. And already aquaculture produces more fish than wild capture fisheries. But that's the overall picture, and doesn't it all? I mean, the media's missed this almost entirely, right? That's only true in Asia. Like, aquaculture represents about 20% of all the production and almost everywhere else in the world, right? And when you look at that, so that's a problem. We really don't see that as a solution right now. And the only people that are really investing heavily into aquaculture and technologies along that is probably China, who need to do it, to feed their populace. So, what would I like to see? I would like to see a recognition that we need to move to more controlled development of our marine ecosystems. And we do that through maybe taking a page from agriculture. So at the end of the 19th century, during the Victorian period, right, and before, but there was a lot of immigration that came out of Europe and to North America, for example, right? And it was because of famines and plagues and people that were being persecuted, and people were just tired and wanted a crack at having a piece of property of their own. But when they got here in Canada, I mean, growing apples in northern Alberta, where it's really cold, wasn't quite the same as something in southern France. And so, as a result, and agriculture was under an improvement phase as well. And so experimental farms were set up, and they were set up here in Canada and the US. And I would like to see the same thing happen in the oceans, where if we're going to move ahead, and somebody has to have that vision in management, and political management as well. But if we're going to move into the 21st century, the end of the 21st century, being much more nurturing the oceans and cultivating them, then we need to get busy and do that now. All of the Western world needs to do this, Australia included. And I think it would make a lot of sense for national experimental platforms or farms, or call them whatever you want, but that it basically becomes the development platforms to test out new species, to basically look at nutritional value, ecological impact, genetic improvement, strain selection, disease resistance, healthcare protocols that need to go on, environmental monitoring protocols to make sure it works. All of that could be done in concert with others. And I've had this conversation with people from the US and Scandinavia and whatnot. And I mean, everybody thinks it's a reasonably good idea, but it really needs to have, some political backing for that. And I mean, that's how farms were done too. I mean, it wasn't a scientist that was beating a drum saying we need a whole bunch of money and people to set up experimental farms, which are still running after 100 years. But we do need to have a concerted effort. And at this point, considering where we are with global changes that are coming with regard to global food production, I think it's probably worthwhile to try and set something like that up. And, that spins off to things like, whole basically private industry that develops certain patentable, you know, items along the way. It comes into environmental monitoring companies, which are already here for the salmon industry for the most part. Comes into certification companies, right? And we talked about the Seafood Watch, but there's another one called Good Fish, which is being developed again by some colleagues of mine. Where somebody can just use a QR code to scan it. It's meant to go into grocery stores where you scan a QR code, and it'll tell you not only whether the fish is good to eat. Monterey Bay uses a red, yellow, green sort of stoplight thing, but I mean this would tell you what you should look for. Like, is this a good fish to eat? Yes. What should you be looking for? Like, what does a fresh fish, if you're living in, I'm not sure where you are right now, but let's say you were in the middle of London or whatever, how do you know what a fresh fish is supposed to look like? Right. And what should you be looking at? What should you be cooking it with? Is it better served fresh or deep fried, or, is it a ceviche or a sashimi? What should you be looking for? And, so we're looking at bigger ways of trying to produce, an integrated industry, over long periods of time. And I think, having new products being developed, tested, because you can't do that on commercial farms, right? There's no way you can really get into platforms because scientists have to break things, right? We need to know where the boundaries are and where the limits are. And if you're in a commercial production where you may have a couple $1 million worth of product in the water, they really don't want you monkeying around with the system at all. So you basically have to go, and a lot of individual scientists can't afford a farm anyway to work on, with an individual research budget. So I think that's where I would like to see things going. I think, I mean, when you ask me how I would provide better food, from the oceans of the future, I think that would be one of them. I think getting an international network of experimental platforms together that are all linked so that, the stuff that we're working on here in Canada would be equally as applicable to Scotland, for example, or to Ireland or to France or to Norway, and vice versa,
But so do you think that scientists have a loud enough voice? Are there enough of you? do you have the political capital to actually... It sounds like you're saying the main obstructions are really monetary and political rather than political will, rather than any physical obstructions.
Yeah, I think that's probably true. I think, if you look at there needs to be a case made for investing in the oceans, which is fair, right? I mean, you need to put a business case forward to do that. I think this should be coming from managers, that are dealing with either the federal government or the provincial governments or state governments, if you were in the U.S. or wherever. I mean, I think they need to realize, what the value of the ocean is and what it could be. Now, to be fair, if you look at the Horizon 2020 projects that were coming out of Europe, where they invested huge amounts of money into things, they realized they had a bioeconomy that they wanted to stimulate. And so, you got to give credit where credit's due to Europe that did that. Canada's not so, it wasn't quite as responsive. We don't have a program like that. And I'm not sure we really see that as a resource that we really should be developing as well as we can. There are institutes, within Atlantic Canada here, for example, that are doing a good job of bringing in entrepreneurs and trying to do some of that. But it's reasonably small scale as to what's needed. I mean, we need a plan to go, and here I'm on my soapbox here, but we need a plan that needs to be looked at in the 100-year time scale, right? Which is like that's like 25 election cycles. And who's going to, we actually need somebody to, like a statesman, to actually look at that and say, here's where we need to go. We need to have managers that have a vision to try and push it through, because it's going to outlast me and it's going to outlast you, right? We're talking 100 years. We're talking about like 4 generations of scientists, that will go through that time.
But on that 100-year time scale, we are going towards aquaculture. Is the prediction that we're going to move completely away from wild capture and 100% of our produce will be farmed? Is that what you think is
No, I
going to
don't think
happen?
so. No, I don't think so. I think we'll probably still have fisheries, but they'll probably be local fisheries. They may be artisanal fisheries where, and, maybe it's not, maybe they get part of their living from fishing, for whatever it is that they need to produce. I mean, ultimately, it'll come down to economics. If we can produce a better fish um, from a culture operation than we can from fisheries, then that's where it will come. That's where the bulk of it comes from. When we're looking at commodity markets, I think economics is going to drive everything,
Hmm.
right? But we still hunt mushrooms, right? I mean, if you go out looking for chanterelles or whatever, if we still there's still wild, there's still people that hunt regularly. I mean, when I go fishing, I mean, the fish that I catch is worth far more than an actual biomass. It's scary to think what it probably costs per kilogram. By the time I get it home and I consider gas and the gear I've bought and the time I've spent and, any beer that were consumed during the trip, it's just, but the point is that people like that. If you look at
Hmm.
salmon, that's exactly the same way. Salmon are probably more valuable for their recreation than they are as a commercial species.
Hmm.
And places like Iceland and Newfoundland and lots of places would kind of agree with that, right? There's if you look at the tour operators that are there.
So, from a management perspective, should we be viewing uh, taking produce out of the ocean as an economic position, producing jobs, this sort of thing, or should it be recreation? Is it cultural? How should managers actually view?
Well, I think that's their job to do that. I mean, it's like they're supposed to be the conductors of this operation, and they need to understand all the parts of it, right? Now, from an ecologist, I mean, our job is to try and understand all the workings of the marine environment from a biological sense, including behavior and the chemical, biological, physical interactions that go on to produce the populations or why they live and how they produce, biomass there. Obviously there's a lot of social issues that need to go on and economic issues because we can't isolate ourselves from those, and they need to be equally as tuned to all of that sort of stuff. So whether we're going to have more, for some cultures, the harvest of a wild fish is an important cultural event. You could look at some of the aboriginal groups within Canada and different parts of the world. That's an important part of their culture. So there needs to be a population that can withstand some of that, right? And if we have recreational fishing on lakes, or whether we need to have people, like in some places of the world, the public can go down and harvest crabs or lobsters or whatever. There's a small daily limit that you could put on that. You go to Washington State and you could you have what, two or three traps that you're allowed to put out to catch Dungeness crab. That is, I mean, that becomes part of their lifestyle and makes that area very attractive to live in, for those that want that sort of thing. There's no reason why we couldn't have some of that going on you know, as well in parts around here. There's lots of lobsters, but the chances that the social and industry perspective is that there's no way they're going to allow recreational lobster fishing here, even though it probably wouldn't affect the populations whatsoever. But in the future, that may very well be one of the things that could go on, and that's just one example of a number of things that we could go on to make the marine systems more productive, more
Hmm.
receptive to new things that would go on, and as a result, we would have probably more protection of them as well. So with regard to dumping of various you know non-optimal ingredients into the ocean, either from wastewater treatment plants or just industrial releases or whatever it might
Hmm.
be, you know if there's a tangible value to it rather than the tragedy of the commons, then you could do that.
Do you think the ocean should be parceled up? You mentioned the tragedy of the commons. Do you think every square meter of the ocean should be owned by someone to prevent mistreatment? Let's say.
I don't think so. I think there's first of all, the ocean's too big to be drawing parcels up. um you know you I mean the you have your 200 nautical mile economic zone, right, from the different countries, and there's enough, jiggery pokery around how some of those lines were set up, with islands creating different zones or whatnot. But the point is that I think that it needs to be treated as more of my personal opinion is that it needs to be treated more as a public resource. I mean, parcel of lands or most of what we're talking about is probably coastal zone, bays and harbors and stuff like this. I mean, if we gave you 10 square kilometers out in the middle of the Atlantic, over the rift, I mean, you would have it and you could do what you want, but you'd never be able to work it, right? I mean, the technology doesn't exist for you to be there, and there's probably a lot better places. So we can't really parcel up the international waters. Even the offshore waters are incredibly difficult. When you're out on a boat, you kind of get to feel what the power is out there and what it actually takes to work and extract. So I mean, you get a real respect for the fishermen that are able to get a living out there. But I don't really see it going private. I could see leasing certain areas if you wish to create an aquaculture zone, or maybe a fishing zone or something like that. But that shouldn't probably be in perpetuity. Maybe it goes on to a 25-year or whatever the appropriate length of time is to do that.
Yeah, so it only really makes sense to parcel up the land, the ocean, if you can enforce ownership.
Sure. And you need to understand what that is. So if we look at the right now, trying to understand fisheries is difficult because the fish don't really respect borders and they go where they will, and they're not random, right? They will follow ocean currents, they'll look for certain temperatures, and those may fluctuate over time, right? I mean, if we have an El Nino or an El Nina, those isotherms may be further north or further south. So meaning, like where the warm water is and the cold water is. And so, those, having boundaries on those may be somewhat problematic, and we may not understand all the things that go around there. But so if you ask me to predict what that particular piece of bottom is doing in the Gulf of Maine, there'd be pretty big error bars around my estimate, right? But if you gave me a certain length of time to study, like 1,000 square meters, right? Off a piece of shoreline here, I could probably, after a while, I could tell you pretty closely as to what was happening there and where where things would be going, where do they normally sit out, and what would happen if temperature went up or down a little bit here. So that gives the point of that is that, if we can increase the food production density in an area, then we can probably study that area. We could focus our efforts on getting much more information, understanding to figure out how that works. Right now, we're kind of all over the place, and there's really not enough scientists working on this whole issue. I mean, there's modelers out there, but they're always starved for data, and we could be doing a lot better job. And I think if we did, focus our energies to understanding an area, maybe it's zoned for aquaculture or for fisheries. The little fishy areas would always be bigger. You could understand a little bit more of the dynamics that were happening there. And as we start looking at things like climate change, like water's warming up around here, right? We're in an area that's projected to have some of the more dramatic temperature changes, and we're seeing changes already, right? With shifting lobster populations out of the southern Gulf of Maine. We're seeing changes to mussel populations up and down the shore. We're seeing changes in whales. The whales, like the right whales, have left here mostly and gone to the Gulf of St. Lawrence, right? After I've been here for a long time now, they've just changed because the food's changed. And so we're at a time when we really need to, we need to pick up our game and do more work on this, as far as I can tell.
This is a question that's sort of out of left field. Do you think, as the proportion of seafood increases coming from aquaculture, Do you think we're going to run into the same sort of ethical questions that we've already seen in battery farming and industrialized agriculture on land? So, for example, chickens kept in extremely small. Are we seeing that, or is this something that isn't
Oh,
popping up yet?
absolutely. No, it's been here. I think the animal welfare, which is what you're talking about,
Hmm.
has been an issue in certainly recognized in the aquaculture industry for. I think I first started seeing presentations on that at various conferences probably 10 years ago.
Hmm.
So there's groups that are looking at whether or not well, I mean, basic things like, do animals feel pain? Well, of course they do. But what kind of pain is it, or do they avoid it, and then do they get stressed? So you could look at things like cortisol levels in the
Hmm.
blood over certain treatment conditions. What happens? And so there's a number of groups around that are they're already working on either describing the situations that captive animals are kept in and things that we don't even think about. For example, if you're going to go on land and put animals in tanks, then you're pumping water. Well, it turns out that the sound of the pumps are stressful to the fish, right? I mean, if we were torturing people, we would put them into an environment where it's noisy, right?
Hmm.
And have this constant noise being fed on them, whether it's hard acid rock or whatever, it's something else. But the point is that they're starting to look at what how the animals are behaving, and there's an overall desire to move to more benign culture techniques, and you can do that because you're controlling the animals. But when we
Hmm.
start looking at other issues that we talked before about what else is going on in the environment, well, for those that use auditory signals like whales and snapping shrimp or whatever it might be, right? I mean, we're putting an incredible amount of noise in the water in some areas,
Hmm.
with ships going by. I mean, I've been diving while ferries have gone by, and it's
Hmm.
amazing the low level hum that comes from a
Hmm.
ferry, as it's chugging by you, and it's a couple hundred meters away, but boy, oh boy, you can sure hear it while you're underwater. So for those animals that are really sensitive to that, then you know there's a whole bunch of things along those lines. Thinking about killing a fish now, right, for harvesting.
Hmm.
Certainly, I don't know if it's really so much in the fishing industry yet, but certainly within the aquaculture industry, there's more humane slaughtering techniques. So as the animals going in getting stunned before it
Hmm.
goes in. So I mean, they're going to be killed, but they're trying to kill them in the nicest way, as opposed to in a trawl, the cod end of a trawl that comes up and dumped on the deck. I don't know what you can do about that anyway, but we're talking about that, right?
Hmm.
There's the Royal Science is talking about some of that sort of stuff now too.
But so, from an ethical standpoint, what would you say is the best seafood to eat? Is it bivalves? Should we view them? I mean, they move, they bury, and they swim. But should we view them more like plants ethically, or more like animals?
I think that what you're asking is a personal choice of where you're drawing the line between sentient behavior almost, right? So, um, I'm for me personally, I'm happy eating meat.
Hmm.
I I I want my meat treated right. I mean, I don't mind paying for it. Um, I we don't eat a lot of it. We eat some fish. We eat a lot of vegetables, that sort of thing. So, do I? I mean, I'm an invertebrate ecologist. If I had to really classify myself down, so I mean, I like invertebrates, but I like all food.
Mm.
I think that's important. And it's important in a number of ways that we're thinking about. I mean, as we're talking ethically, yes, I think we should be as ethical as we can in our food production. There's, I mean, there's no reason for ignorance in how your food is being produced. But if you're eating chickens, then you're basically condoning the slaughter of chickens,
Hmm.
from however they were produced. Um, but I think that our diets that we have and have evolved and changed over the years, I think they've been modified dramatically to industrial farming. And this is a slightly different topic that we're talking about, but ethics leads into what sort of foods should you eat that are the best for them, and well, maybe not best for them, but because everything's going to die to get into our pot. But I think that I think what we should be careful of what we choose for foods,
Mm-hmm.
and I think eating a wide diversity. If you look at you could look at seafood or food in general as not just nutrition that we're shoving into our bodies to get us from today to tomorrow, but food is also an integral part of our healthcare plan. If you look at better diets, I mean, poor diets inevitably lead to poor health outcomes, whether it's obesity, diabetes, whatever. And there's lots of studies to show that. The World Health Organization was recommending food because prescriptive medicine is basically bankrupting most Western societies right now with regard to trying to keep their healthcare systems running. And so keeping people healthier, and turns out a lot of the newer human research that's going on into microbiomes. So the bacteria and
Mm-hmm.
fungi and viruses that naturally live in your body, right? They produce compounds which are basically health promoters that go on. So you can read um, books like Brain Maker by Dr. Perlmutter, somebody Perlmutter. Anyway, I mean, they're talking about how a lot of these links of food are basically giving us better healthcare outcomes. So to take this back full circle, if healthcare is one of the outcomes of better food, and better food is, as a result of ethical choices, then we can get a win on that. And if we can get better health care outcomes from our foods and diets, then that comes back into the whole economic thing, because healthcare in Canada is one of our biggest budget items. Healthcare and food and oceans are not just some little cute fish stick, that's being breaded and sold with chips somewhere. I mean, we're talking about a potential major social change to society of seafood and food coming from the sea. And that doesn't even take in what the new stuff is, right? Whether we eat more seaweeds in our diet in whatever form. I mean, they don't all have to look like a Japanese restaurant, right? I mean, if there's lots of chefs that can make, some incredible dishes using, marine-based products.
So for someone who doesn't eat any fish, someone who's listening who doesn't eat any at all, if they switch out, one beef meal for a plate of fish, what are those benefits?
Well, the benefits that you have from eating fish, and it's, I can't give you a cost accounting like if you invest this much on fish, you're going to get this,
Mm.
benefit out of it. But if you look at fish, the first thing you get is food replacement. So, and God knows I love a good sausage as well. But if you look at a sausage, there's not very many long chain omega-3 fatty acids in a sausage, right? So if you had a piece of fish for that, now you are going to get it, particularly if it's an oily fish, or if you eat mussels. There's also lots of long chain omega-3 like the EPA or DHA, the eicosapentaenoic acid and the docosahexaenoic acid. But those are the long chains that we can't make. They're called essential fatty acids. They originally come from plants, right? And they get like mercury concentrates in a bad way up the food chain. Fatty acids get also accumulated up the food chain, which is why you can get them in oily fish, right? Who basically get the benefits of a whole bunch of poor little algae making it, several trophic levels ago. But, the point is that you're going to get that from eating fish, and you're going to lower your saturated fat intake from from beef or pork or whatever it is. I'm not saying don't eat them. I'm just saying that you need that balance in there, and that balance that you're eating has to go in, and it'll help your microbiome if that research is. I mean, there's no question that it's a brand new field that we're going to go into, but I think it's time we recognize what that is, and your diet is a major source of what your overall health is going to be. So,
On
did that
the
answer your question?
somewhat, I was wondering if you had sort of specific, it helps your brain, or it'll
Oh,
help your
sure.
heart. Hmm.
Well, there's lots of things. I mean, there's a replacement of bad things, but I mean, if you're getting more omega-3s into you, and there's nutritionists that can answer this far better than I can, right, with the details. But but there's but the long chain omega-3s are important in brain development. They're important in nerve transmissions. They're involved in cell membrane integrity and that sort of thing. So all of those things are things that we would want. With regard to brain recognition, if you think about, the development of young children, right? I mean, there's a perfect example. And you can see some advertisements on television for some yogurts, that are enhanced with omega-3s or something like this for brain development or whatever. So I think, yes, there's lots of reasons to think that we need to get more omega-3s rather than omega-6s. So omega-6s are plant oils, and we're sort of really highly saturated with those. Like, we eat a lot of those and not so much of those.
Back on the ethical side of eating fish, just to hammer on this path a little bit more, do you think there's a bias? The average person, they see a fish in a tank or on the end of a line struggling to breathe. Do you think we have a bias against the intelligence of fish? You've spent a lot of time with a scuba tank on your back. So do you think if more people could see fish in their natural environment, we would have a shifting bias or a shifting window for how intelligent we think fish are?
I don't know. I think it depends on the fish, and depends on what we're talking about with intelligence. Like the intelligence of a fish to maintain itself in a school, to avoid predators, to feed while you're in if we're talking about schooling fish or something like that. There's a huge range of things that we'd never see. Would we say they're as smart as chimpanzee? Probably not, but we're basing our chimpanzee intelligence quota on us, on what would we do, and how close is it to the epitome of humans. Whereas if we put a chimpanzee in a school of fish, it wouldn't keep up at all. Of course, it's not morphologically adapted to do that, but it doesn't have a lateral line, which is a pressure sensitive organ on the side of fish that can detect pressures, and so it keeps it in the school. I've been diving where I was working on an artificial reef that I put down on the bottom near a farm, trying to recycle some of the nutrients that were coming out of the farm into other products. And I was seeing this little sculpin. So a sculpin is sort of it's sort of like a large-headed benthic bottom fish. This one was only, I don't know, maybe 10 centimeters long, perhaps. Cute, had little spines on the top of it and stuff like this, but he was staking out its territory. So he'd set up territory on this plastic artificial reef that I'd set down. And although I was, I don't know, 500 times his size, he wasn't giving up any ground, and, so there's behaviors. Is that intelligence? I don't know. But, I think they're as smart as they need to be to live successfully where they do. Mm-hmm. And so if we're going to be judging, intelligence of fish, I think it depends on the perspective you look at them with.
Yeah. So you said that you started your career researching the giant Pacific octopus. Did you ever swim with them? What's it like with them in the ocean? Because that must be very intense.
Well, they can be. Yeah, it was lots of fun. There's no getting around that. So I was diving on the west coast of Vancouver Island, and I was looking at growth rates of them. So I was putting a tag on the octopus, and step one would be to dive down and look for an octopus den. So a den is basically a hole under a rock, and it can excavate it. So an octopus is sort of like it's got a siphon to it. So basically it can take water in and blow it out the siphon, like a squid does as well. And so it would create a little den underneath a rock or in a crack or crevice. And it would have all the animals that it eats, like clams and crabs and abalone and stuff like this, would be in a garbage heap just in front. So it's called shell midden. And so you go find those, and we would then get the octopus out. We'd put sort of like an irritant in the den, so like a tear gas, and the octopus knows that there's something out there. I mean, they're incredibly intelligent. So
Mm.
they would need to get out, but they'll put an arm out first and they'll kind of wave it around, and maybe something will take a bite of the arm and then they'll bugger off and then they can come out safely. Um, so you wait after that and they come out and you can scoop them up. Well, they're really, I mean, they know what's going on, and
Mm.
they're so you have to kind of hide so they don't see you when they come out. And then once they come out of the den, and they'll always leave one arm kind of trailing inside, you have to swim really quickly and then lift them up and get them up in the water, and then you can put them in a goodie bag where we put a tag on them, and then to identify them, I'd weigh them and do some measurements on them and take them right back down and put them back in the same den that they came from. And but they were, I mean, they're incredible. They're obviously ranging out every night. They grow like crazy. I had some growing at the Vancouver Aquarium, and they're incredibly efficient at processing food. They're quite sensitive. You see them in an aquarium, they'll often be up in a corner or somewhere, right? They really want to be hiding. And but it gave me a feel for they're, when you watch them, when I had them at the aquarium, I could watch them feeding on crabs and whatnot. And oh yeah, it was like a bat from hell coming down on this poor crab. Like they just launch themselves on it, and the crab gets two pinches and then arms pull those off and then he's eaten. So but they're top predators, or one of the top predators on the bottom, although they're obviously prey for things like dogfish and
Mm-hmm.
other octopus, for example. Yeah.
But how big do they get? They're not dangerous to humans, or?
Oh no, they're not dangerous. I mean, the biggest one I probably caught was 30 kilograms, maybe.
Well,
But
that's
a
pretty
30
big.
kilo, yeah, it's pretty big. I mean, it's called the giant Pacific octopus for a reason. So, at that 30-kilogram octopus would have arms that would hang down probably 2.5 meters, maybe.
Yeah.
So it was big enough that when I caught that one, it grabbed my fins, and um, I had him and he had me, and we just kind of settled back down to the ocean bottom. And my buddy came along and we got him in a bag and tagged him and brought him back. But they only lived for a year or two,
Yeah.
and they're done. So
But if you were alone with that octopus, could you individually put it into the bag, or is it way too? Because it's just pure
yeah,
muscle, right?
yeah. But they're just trying to get away. So
Mm-hmm.
I mean, I've caught them by myself before. So it's I mean, bigger ones are obviously harder to get into the bag than smaller ones, but
Yeah.
um, it's just a technique. And like I say, they're once you're comfortable down there, they're not big and aggressive. I mean, they come out and they look all badass because they puff themselves right up. But once you pop them in the bag, they're pretty docile.
I'd love to see one. I've seen almost no octopuses while diving. I'd like to see that, and maybe a Humboldt squid. That would be also very intense.
Yeah, that would be intense. I
But
think I'd want to be in it.
you'd
I'd be
want to
in a
be in
submarine for
chainmail
that.
or something.
Yeah, I don't know.
So I want to wrap up the conversation with some questions about the future.
Mhm.
So, very simple question. What's your dream for the future of aquaculture, for fish farming, for seafood farming in general? And what are the developments that you're excited to see?
Well, I think we've talked a little bit about the like my desire to move us towards an international development of a chain of farms or whatever around the world to develop techniques. I think I think that's my vision for the future. It's probably one of the more important ones. And I don't think we have forever to do this. Like, I'm not sure we have 100 years to do this in. Um, if we look at around the world right now with regard to social change, right? I mean, people coming out of Syria, people coming out of areas, well, even the Ukraine right now. We're seeing economic migrants, we're seeing war derived migrants, moving. But I mean, if we can't control our climate or get our climate under control, And we've run into droughts. I mean, if you read books like, from Jared Diamond, I don't know if you read any of his stuff,
Guns,
right? I
Germs,
mean,
and Steel.
Guns, Germs, and Steel. But his second book was called Collapse, and it's
Mhm.
why societies chose to fail. And like a lot of the reasons for societies collapsing was due to droughts. And we're on that trajectory right now. I mean, if you look at a lot of agriculture around the world, they're drilling into aquifers, which are old historic water, and using that. If that's not being replenished due to an existing current drought or long-term consistent drought, we're going to have a whole bunch of other people looking to go somewhere. I mean, Canada has lots of water, but a lot of people in the US may not. So where are they going to go? And how are we going to feed them if agriculture goes down? We're looking at projections at and I know this is a bit of doom and gloom, but I think this is the reality that we should be looking at and trying to develop. So that's why I think we need to look forward a little bit more, maybe a bit more exhaustively or broadly, to see where do we need to go. That's my biggest. If I had one complaint about management, it's that there's no vision as to where we need to go. And maybe that's because of a 4-year political cycle or whatever it is. But I don't think we can afford that luxury anymore. I think I think we need to make a decision as to whether or not we need more food. If the answer is no, fine. If that answer is yes, then where are we going to get it from? And if we're going to get it from the oceans, then we need to get busy. And we need to have that ready, because I mean, just to develop a single species in aquaculture takes probably 15 years. Right? But from the time the basic research starts to trying various, prototypes and, phase 1, phase 2, and then, from research and development to commercialization, is probably 15-year period. So, and if we need multiple species and we need it more sustainable and blah, 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 we need to get started. So that's one of the things I'd see for the future. I think we need to, all my analysis, and we talked about some of it today, was that I think we do have a food crisis coming up in the future. And I think the oceans can be a solution, a partial solution to some of that. But I think that we need to get busy and do something before all of a sudden we're in a crunch. Like we're seeing more storms and hurricanes. Fisheries projections are only down. I don't know of any fisheries that are projected to go up because of climate change. And at some of the aquaculture conferences I've been at, I mean, they're projecting things like rice to go down in production, like 10, 20%, whatever it is. I mean, that's huge numbers that are going to have to be replaced with something, right? And I think that I think I sent you a presentation early on with the last slide was, I mean, I honestly think that first world countries, G7 countries or whatever it is, have a moral obligation to do research that benefits other parts of the world, like the global South as well. So, I mean, maybe that's my socialist tendencies coming out, but I think that honestly, we have a responsibility to do that, and it's no sense pointing fingers when we're in the crisis, right?
This is actually something that I had not appreciated immediately, but when you look at the number of liters it takes to produce, say, a kilogram of beef, so how much water you require, is that completely taken out of the calculation when it comes to seafood? As in, you can effectively say there is 0 liters of water required to make a kilogram of salmon?
Yeah, it's I don't know. Technically, there might be a bit of water that goes into if you're looking at prepared diets or something like that, but it's minuscule. I mean, the fish don't drink, right? They're in an aquatic environment and they're getting the water that they need. They excrete the salt out of it or whatever. So the amount of water it takes to grow fish, other than the physical medium they're growing in, is less. Freshwater, so that's in the ocean. In the bays and freshwater rivers, you'll still need that physical presence of water to grow them in, obviously, but there may be less and less of that, right? Do you want, if our water supply goes down and more of it needs to go to be dedicated to human drinking supplies, do you really want a fish farm operation in your drinking water supply? Probably not. But at the same time, do we want industrial effluent running into our drinking water supply either? So, there's a bunch of, spin-offs. Freshwater is probably a little bit more problematic, although it produces an awful lot of aquaculture, like fish, just not in Canada or the US or Europe. I mean, it's more in China.
Mm-hmm. What about on the carbon side? Do you know if you looked at the carbon footprint of, say, a kilogram of, again, salmon, let's just stick with something that people know, how does that compare to this, a kilogram of beef?
Yeah, it compares well, but I can't say I can give you numbers right off the top of my head. But they've done an analysis, like a what's called life cycle analysis. Um, and there's some people at Dalhousie University that are doing some of that, and they do that cost accounting in either what do they use? Let's do with global warming. I can't bring it in off the top of my head, but I know that aquaculture is compares well to
Mm-hmm.
for carbon loading.
So essentially, the message, if I understand it, is if you look at all sorts of metrics, from carbon footprints to water usage to nutrition and health, then really aquaculture is a sensible thing to look at. And if you want to put things in place in time for them to actually have a positive effect and really be useful, you have to be thinking on 15 or 20-year horizons at least, because that's how long it takes to pull in a new, or do the research for a new species or a new supply chain, let's say.
That's right. So that's for producing one of the nuts and bolts of this system, right? So if we're looking at a single species, but what if you want that species to exist in an ecosystem? So one of the things we were working on earlier on was something called integrated multi-trophic aquaculture, which is
Mm-hmm.
big mouthful, basically means mixed farming, but a selection of species for that mixed farming that are complementary to each other, right? So
Mm-hmm.
for if you're putting a fed species in, maybe it's shrimp, maybe it's fish, salmon, they're going to eat, but they don't assimilate all of their food, right? A lot of it goes out either as ammonia, or it comes out as basically a carbon heavy fecal pellet or whatever, right? So that waste, because they strip a lot of the good proteins out and a lot of the fats come out of it, and so a lot of it's carbohydrates left. That goes out, but that can get picked up by filter feeders, right? Those could be worms, those could be mussels, those could be whatever, oysters perhaps, that go down. And this is being tried in different parts of the world, but those are all releasing nitrogen. So that's an inorganic molecule as opposed to a fat or a sugar or something like that. But that's what plants use. So seaweeds can soak up ammonia, or sometimes ammonia gets converted to nitrite or nitrate by bacteria. But anyway, that's an inorganic molecule that can be taken out. So it runs in that concept: if you put it in, you should take it out.
Mm-hmm.
And so this is another way of extracting some of it from the ocean. That if you're putting nutrients in from food, if you're feeding something, then you can get that out. Maybe you don't have to do that. Maybe you skip the fed stage and you put in things like shellfish,
Mm-hmm.
like filter feeders of mussels or oysters or scallops or clams or whatever you choose your species, and then you put seaweed in with those, and those systems are going as well. Understanding the loading and the dynamics and the balancing between all of those different trophic levels are more complicated, because you don't only have to know the biology of the animal you're talking about. You have to also know about their interactions with others and what the physical environment is doing. Like, what's the spread of a nitrogen or a series of nitrogen molecules from a source? Let's say it's a sock of mussels. How does that go out, and how does that diffuse, and how close do you have to have your seaweed in order for it to capture anything? Because in a lot of cases, as soon as you release something, like you stir milk into tea, I mean, it goes white almost immediately, right? If you put a nutrient in the ocean, it also diffuses out in a cloud. sometimes currents and density differences can concentrate it a little bit for a little bit longer, but there's a whole lot of more information required in order to build those more integrated systems, but those might be more ecologically feasible in the long term if we're really seriously going to manage our marine environment. And those same processes could be used in terrestrial systems too. They just haven't got there yet. Although they are using things like predators. So instead of spraying, with pesticides, they're using predators of their pests that they have, right? So you can buy commercial quantities of ladybugs, for example, or ladybird beetles, or praying mantises, or whatever, to eat the predators or the pests that are eating crops. So there's, we're slowly moving towards a more ecological approach to producing food.
The immediate thing that springs to mind so the picture I have is that you have a farm where you have, say, for example, fish swimming in some tanks, and below you might have some shrimp, and you have some algae or whatever it is in the immediate vicinity. But the question that I have is, these fish in the wild may swim over huge distances. And as you said, you've got diffusion in the water column. Can you get physically enough, can you get enough oysters or whatever it is that you need in the vicinity of the fish farm to actually make a difference?
So you bring up a very good point, but you need to expand your thought to, we need to look at things other than the status quo. So maybe this sort of approach is not really going to work well for open ocean, open net cage things, but maybe it works really well for on land culture, because now you control all of the flow, right? And there's systems now, I don't know if you've heard of them, they're called aquaponics. So what you basically have is a fish tank, and that water gets the water from the fish tank, because the fish are respiring and producing nitrogen the same as us, and that goes into the water, and that water, they filter it usually, I think, but so there's solids, and then there's the dissolved part of it. That dissolved part goes down to beds of plants, right, where the bacteria and the roots of the plants and the systems are converting all of that ammonia to forms that the plants can pick up and grow. So whether you're growing flowers or lettuce or wasabi, or choose whatever valuable plant you want. I mean, there's talk. I mean, I suggested early on they should, because marijuana is legal in Canada now, and there's farms growing marijuana in controlled conditions, of course. I mean, why wouldn't you use the nutrients from a double crop to produce more revenue, recycle it? I mean, there's so many creative people out there that they're just not being diverted to aquaculture, and I think, if we had more entrepreneurs, and if we had a real formal system to do that, we could come up with some pretty clever systems, for vertical integration in culture. They're talking about doing some of this in cities, right, where you just take a building and put it in. I haven't really seen any working yet, but I think it's all coming. It's all coming.
Then let me finish by asking you a fairly simple question, but I guess you could take it really in any direction you wish.
Which I've done all day so far, right?
Well, so the question is, what do you wish people knew about the seafood that's on their plate?
I don't know how to answer that question. What do I wish they knew about it? The fact that they've got seafood on their plate to begin with, I think, is a good start. I think I would like them to know more about ways of preparing it, and the different presentations, and the huge array of things that are available to them. So it depends. So if you ask me, if I was sitting in Portugal, for example, and you and I were having dinner with friends in Portugal, some Portuguese friends, what would I wish they know about fish? They probably know more about fish than I do. about about what to eat and where it's and when it's available and when the best time to eat it is and the different preparation methods for it. And so I'm pleased they know that. Be nice to they may not know about some of the healthcare implications of it or how it affects microbiomes within them, and whatnot. I mean, those are all sciencey technical details, but not that they're not important. But I mean, if all they knew is that they needed to get more fish in and they should eat a wide range, then that's probably good enough for them, right? I don't need to know exactly how my cell phone works. If I was eating with somebody, let's say I was eating with my relatives who live in Ontario in central Canada, right? To treat every gram of fish with great suspect, right? And, I mean, they wouldn't stay in the same room if we were boiling lobsters, and just the odor that comes off from the lobster cooking is enough to make them flee the house. I mean, it would be nice for them to know, there's good reasons to eat fish. It would be nice to be able to say that all of these fish were sustainably harvested or caught or produced or whatever it is, and that they're good for you, and that they were prepared by chefs. I mean, most people get turned off by fish because the fish isn't very good, right? I mean, there's certain fish that sort of have a certain taste to them, but if you get a good chef producing fish for you, then I mean, you should hear angels singing, with regard to the food you eat with a good glass of wine, and there's nothing better.
See, I didn't expect this. You've surprised me then, because I didn't expect it to go down in the culinary route.
Yes. Yeah, but what would you ask? What would you want them to know about the fish? I mean, there's so many levels about that with regard to biology. I mean, you could talk about biology, but that's really only really, really interesting to biologists, right? And, you get a bunch of scientists all talking, and they're talking about biology for the most part. If you're going to talk to them about how they were harvested, that's changing. I mean, I think if you and I have this conversation in 50 years, this won't be what we're talking about at all in fishing. I mean, there may still be some fishing going on. I think it's going to change dramatically. But I've been wrong before. But I think that, this is sort of like a temporal topic. What else do we want them to know about fish? I think there's, that it's part of our food system, and it's part of the ecosystem on the planet that, I think it needs to be treated with respect. And if we're going to harvest them, then we need to do it the right way. Or culture.
Well, the purpose of the question was to open up a bit of your personality and get and it did its job. So yeah. Shawn Robinson, it's been an absolute pleasure. Thank you for coming on the podcast, and you're welcome back anytime.
Anyway, thanks. It was good fun. Yeah, I haven't done something like this before, so it was good having a chat with you.
Final question, which is unrelated to anything we've said so far. Where is the best place to go diving?
Where in the world?
Yeah. Where if you could recommend some places to go diving, where would they be?
I've done most of my diving in temperate water. I have been diving a bit in the Bahamas. I did a tiny little bit of snorkeling in Venezuela, but those aren't really the destination places where you go. If you really wanted to see tropical reefs right now, well, I would go to your home state of Australia to get on the barrier reef. It's in big trouble right now, so you probably should go to look at it while it's still got some pristine value. Indonesia is apparently a very good place to go diving, although I've never been there. But it depends what you want. Like, lots of people want to go see bright, shiny things, and that's not necessarily me. I mean, I'm interested as an ecologist. I'm interested in all sorts of different areas. I mean, one of the early dives that I took wasn't with a scuba tank, but was in a submarine, and we were dealing with Saanich Bay. So this was in the early 90s, and so I begged and pleaded to get on the research submarine, and finally they let me go, just to shut me up probably. But anyway, we sank down through the water. So we're in 200 meters. Do you have to go just out of
No,
curiosity?
no, no.
No. Okay. Um, so we're in probably 200 meters of water, and Saanich Inlet is fairly deep, but it also has a sill. So in oceanographic terms, a sill is kind of like a wall. Like if you think of a fjord
Mm-hmm.
going in, well, it's not all river valley all the way along. There's some smaller mountains sitting there in the valley, and so there's a bowl that's created in behind it. Okay, so it sills, and so that means a lot oceanographically, is how water comes in and out and oxygen exchange and blah 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 blah. Right. Well, it turns out, so we're sinking down into this Saanich Basin, and it was the first time, like I'd done lots of plankton tows and whatnot by then, but it integrates everything as you pull a mesh plankton net up from, say, 20 or 30 meters or whatever it is. You get a bunch of stuff in a jar at the top, but you don't really see the structure in the water. So as I'm sinking down, you can actually physically see it getting greener down around 7 or 8 meters, because that's where the phytoplankton concentrate. And it's because the light levels are optimum, so they can adjust their depth to get down to that level. And then you can see a copepod layer where the copepods are, for whatever reason they're doing it. Maybe there's better oxygen, they're not that far away from the chlorophyll max, or this phytoplankton layer, because that's where their food is. And then you go down further and you can see euphausids, which are like a big shrimp, a midwater shrimp. And then you go down there and there were spawning herring. And then we sank down. So you see these layers in the ocean that are happening out there, and they happen all the time. We just don't see them. And then as you drop down, we got to effectively the top of the sill, although we couldn't see the sill, but it creates, because the water doesn't move, the bacteria remove all the oxygen from the water, right? Because they respire, same as you and me.
So there's a dead zone.
And so it creates a dead zone, except for the anoxic, or the anaerobic bacteria, right, which don't need oxygen. They'll use sulfur or something like that. But it changes the properties of the water, and the water goes like a diluted milk. And so you're sinking down through this really dilute milk to the bottom, and all there is these sulfur bacteria, on the bottom in mats, and dead things that have fallen or died and fallen into this, and are slowly being decomposed by these bacteria. And then as the submarine gets to the bottom and then goes up the bowl, and you get towards the edge of the milk bowl in the bottom, all of a sudden you start seeing some things which can hold their breath, or whatever, stand a little bit of anoxia, to run in to grab some of the dead things and pull them out so they can eat them in the oxygen layers. And there's shrimp and prawns and octopus and fish and stuff like this as you get out near this interface, because of all the dynamics that are happening there. And it's like seeing stuff like that gives you a feeling for how important it is, not only to see it, but also gives you a feeling for the complexity. Because if all you ever did was pull a net up, you wouldn't get the feeling for what that three-dimensional structure was, and all the dynamics that are happening within that. So cameras are helping us a lot now, and drones and ROVs and all that sort of stuff. But I don't know, it's been like those sorts of dives really left a strong impression on me, on the importance of as an ecologist, of trying to see this sort of stuff and get a really good feeling for the dynamics that are going on. Because you could drop an oxygen meter down, and you could tell where the bowl was and how deep it was, and you could describe it physically, but it doesn't come close to showing the dynamics that are happening within that.
Does it change your perspective of how important you are? Because it's like an alien world. That there are all of these lives that are going on completely separate to you. Mm-hmm. It doesn't matter if you're here or not. They're just doing their thing and going on. Does it sort of change your perspective of your place in a world? Or
oh, sure. Oh, yeah. I would have to. Well, I'm a bit bizarre anyway, in the sense that I look at all life through a biological lens, including humans. So I think that we're quite a bizarre species. We're fairly in love with ourselves and egocentric, and we think we've isolated ourselves from any density dependent processes. So, when you think about, any species, when Trevor was talking there last time, you were asking him, do you think we've replaced ourselves as the top predators? And, replacing sharks or whatever it was. And I, I would say not quite, because sharks are part of the ecosystem, have been a part of the ecosystem for, millions of years. And they're subject to all the forces that happen to things within the ecosystem. So if food goes up, yeah, then you're go ahead, have more sex, have more babies, all that sort of stuff. But when food goes down, then your numbers go down. Or if there's a disease that comes along, because your densities are too high and it's easier to spread, the naturally existing pathogens around, and they get to, epidemic levels. Okay, great, you're done. But humans aren't like that. We out engineer. I mean, think of COVID, right? I mean, we brought vaccines on the market, so nobody, relatively few of us are actually going to die from COVID in comparison to those that get exposed to it or something like this, as opposed to, like Yersinia pestis, the Black Death back in the, Middle Ages. So, we're not really top predators because we don't fit in the ecosystem. We engineer everything to stop. And when our food supply was going down, in the Victorian period, what did we come up with? Artificial fertilizers, because we didn't have enough manure to go around. So we came up with artificial fertilizers, right? When we're thinking about climate change or trying to out engineer climate change, we're not going to modify our practices or our birth rates or anything like that. God forbid, So I don't know. We're a weird species.
I guess the exciting thing is also right now you can sort of see we're on the verge of very soon we might have a situation where we really can pull ourselves away from the natural, circle of life. We will be able to have indoor farms, let's say cultured meat, and completely separate ourselves. It doesn't seem so crazy that we could one day do this.
Maybe, I don't know. But I mean, we can take the Star Trek view of, we'll have our food replicator, build whatever we want. But that's based on ignorance, right? I mean, we don't understand the role that, I keep coming back to this microbiome, because I think this is such an incredibly important new wave, within human history, that we're actually finding out about this, maybe too late. But, I think there's intangibles that are happening within the microbiome. And if you want another show, that would be a perfect one to talk about. I mean, with regard to human health and whatnot. It's not so much in the environment yet. I mean, we're using it to, there's some real clever guys doing some of this down in New Zealand, Xavier Pochon and Nigel Keeley. But, the human health is driving a lot of this science and what's happening with it. I'm part of an international group that's working on it. A bunch of Europeans. It's mostly in the Atlantic right now, but includes South America as well. But they're looking at, one of the things that's happening with climate change is that sea levels are rising to a certain extent, right? So this is flooding, not in a major way, but salt water is intruding into low areas they're growing out, and some crops are not able to handle the slight increase in salinity of the water, right? So it's gone from fresh to low brackish. But if you have a certain bacterial population in there, apparently that can help the plants adapt to some of this stuff. Who knew, right? But as opposed to having a successful crop or no crops, that's a huge thing. Some of that stuff is coming out of the Netherlands. There's a guy over there I know who's doing some work there. So much stuff going on with regard to this new science, all because of the genetic technology that's come out, so they can actually identify things.
Still, I think if you push the boundary out enough years, then I can imagine the Star Trek world. Even in my own ignorance, I can I can imagine us getting there one day.
Right. So maybe that's and maybe we do get there. I don't know. Maybe I'm more in the, if you look at the Lord of the Rings, saga, maybe I'm more of an elf that feels that we have to live within our environment. I mean, we could engineer, but it's a deterministic view somewhat that you're looking at. And that, because we don't really understand all the nuances of actually even how we live, like we still don't even know what we should be eating exactly. I mean, and now we're going to head out on a brave new world, to infinity and beyond, and grow our own foods. Well, maybe we can produce the basic nutrients we want, but maybe there's a whole bunch of micronutrients or whatever that are being produced by the bacteria, like in our systems. And they've already shown they do that. The question is, so they do that through prebiotics, is the name for it, right? And that's basically those things in our diet that those particular bacteria need, and it may not just be the assemblance of amino acids and fatty acids, put together in some carbohydrates, into a 3D printed burger, that's going to give us everything we need. And I mean, we could die out quite easily if we didn't have those micronutrients, or we'd have to evolve, or the bacteria would have to evolve to do something else. And whether that can happen in time, I don't know. But we don't know enough about it to really project it. But I don't know of anybody that's really looking at that either.
Maybe this is one of the strongest arguments for trying to colonize Mars. It's gonna force us to learn this stuff.
Maybe. And I think, but we tried some of that. Like we wouldn't even have to go to Mars necessarily. I mean, we tried, what were the name of those enclosures? Biodomes or something like this. There was
2, I think.
Well, there was 1 and 2, right? I mean,
I think one is us. One is the Earth.
No. These were the ones that were in California, right? So they basically put people in, that was in there. It came out of the 70s or 80s, maybe. And they tried to put in this self-sustaining, entity that people lived in, and they were supposed to stay there for a year or whatever. And I think that it was, I forget the name of it, but it was a dismal failure. Not only because systems didn't work exactly the way they were supposed to in the long term, but also social problems people had living in close quarters and da 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 da. So I don't know. Maybe we go to Mars. Maybe we take Matt Damon with us because he seems to be able to grow potatoes there, right, and survive. So,
I think the problem with Biodome 2 was that they didn't factor in the curing of the concrete in the building, so that sucked up all the oxygen. But I think after you've had a few colonies die, you work out the concrete issue.
Well, it's cool stuff, no question. I mean, it gets a lot of people out of bed in the morning, and I've been reading some of it. I like the whole tech side of it, and the fact that they're talking about sending up 3D printers up there to build everything. So just using the sand and dust and creating building structures, so we don't have to take up plywood with us to get there.
I mean, on the other side of things, if we do this, it might help us to appreciate what we actually have here on Earth.
Maybe, yeah. I mean, providing we don't get to a point where we have to leave because it's so crowded and that we've ruined our planet, right? It's like what was it called? Was a movie that was about how you just, anyway, Dumb and Dumber, people like what was it called? Idiocracy. That was what it was called. And I don't know if you've watched it or something like this. It was a bit of a cult thing. Yeah, I thought it was too. And it's obviously not true, but you could see the premise going on, and so I don't know. Maybe some of your work needs to go on. I mean, if you're looking at bouncing galaxies, then maybe you can project these wormholes so that we don't have to take forever and a day to get there.
I think if we're relying on my research to save humanity, we're in big trouble.
Oh, is that right?
But,
okay.
Yeah.
Yeah, you need a marketing man then, obviously. Yeah.
Yeah.